All right, so today we're going to pull back the curtain on the engineering that goes into modern enterprise applications. You know, the really big ones, the kind that have to be incredibly fast and work perfectly for anyone, anywhere in the world.
So let's just get right into it. We've all been there, right? You're using some big, complex business dashboard, and every single click, every scroll, it just feels heavy. It's this universal frustration. But why does that happen? What's the deal with all the slow, clunky software?
And, performance is really only half the story. The other massive challenge is making software work for everybody on the planet. And this slide just shows it perfectly. On the left, you've got your standard English interface. Looks great. But look what happens when you flip it to a right-to-left language like Arabic. It's a total disaster. Everything's broken, misaligned, a complete user interface nightmare.
Okay, so these two giant problems, the sluggish performance and these completely broken layouts, they don't just happen by accident. They're actually the direct results of some very specific, kind of outdated ways of building software. So today, we're going to name names. We're going to identify the two main culprits responsible for all this.
So culprit number one for all that slowness is something called inefficient change detection. In older apps, when even one tiny thing changes, like one number on a huge dashboard, the entire application basically has a panic attack and checks everything just to figure out what it needs to redraw. I mean, that analogy on screen is perfect, right? Imagine a manager rereading a 1,000-page report just to fix one typo. It is a colossal waste of effort, and it's what makes the app feel so slow.
And culprit number two, the one responsible for those broken layouts, is what we call brittle style maintenance. The old way to handle different language directions was, and this is wild, to literally maintain two separate design files, one for English and a completely different one for Arabic. Not only does this double the work, but it's just asking for trouble. A developer updates one, forgets the other, and boom, the entire UI just shatters.
But what if you could fix both of these huge problems at the same time with a totally new approach? Well, that brings us to the real heart of this whole thing, a two-part revolution that is a genuine paradigm shift in how we build software.
For the performance problem, the answer is to just throw out that old check-everything model. The solution is called zoneless reactivity. Instead of the app constantly asking, hey, did anything change? Did anything change? The data itself just announces, hey, I changed. This lets the app make these tiny, surgical precision updates that only touch the exact part of the screen that needs it.
And for the broken layouts, the solution is just as elegant. We stop trying to manage two competing design files. Instead, we move to a single, universal layout with logical CSS. This way, developers write one smart set of rules that automatically and perfectly adapts to any language's direction.
So we know the what and the why. Now it's time for the really fun part, the how. We're going to pop the hood, look inside this new engine, and see exactly how two specific technologies, Angular Signals and Tailwind CSS, actually make this whole revolution possible.
Angular Signals is the tech that gives us that incredible performance, and it's really just based on three simple pillars. First, there's a signal, which is just a little wrapper that holds a value. Second, you have a computed value, which is derived from other signals and only recalculates when they change. And third, you have an effect, which is just an action that runs automatically whenever a signal it's watching changes. It's just a really clean, direct, and powerful way to work.
And the best way to understand this is with an analogy. Think of it like a smart document. Instead of having to reread the entire thing after an edit, you just get a precise little notification telling you exactly which sentence was changed. That's what signals do. They give you this super fine-grained reactivity. No more wasted effort.
Now for the layout solution. This table really shows the magic of logical CSS. See, instead of writing a rigid rule like padding left, a developer writes PS4, which just means padding start. Now, if the browser is set to English, it knows start is on the left. But if it's set to Arabic, it knows start is on the right. It's one rule, two perfect outcomes, all handled for you automatically by the browser. It's brilliant.
The ambidextrous design analogy is just perfect here. The design isn't built to be left-handed or right-handed. It simply adapts to the user's needs, and it works flawlessly either way. It's just a much more modern and, frankly, more inclusive way to build things. So it's really important to know that these new technologies weren't just picked out of a hat. They were chosen after looking at all the alternatives. They really are a better path forward. So let's quickly break down the trade-offs and see exactly why this new way wins.
So first up, do these newfangled signals replace an older tech called RxJS?
The verdict is no. They're partners. RxJS is amazing for handling events over time, like data streaming in from a server. Signals are perfect for holding the final value that you want to show on the screen. The best practice is to use them together, letting each one do what it does best.
And when you put Logical CSS up against the old way of doing things with multiple style sheets, well, it's not even a fair fight. Logical CSS has zero extra complexity because the browser does all the work for you. It gives you a single source of truth, which cuts maintenance in half and makes the whole system way more reliable.
Ultimately, it all just boils down to this one simple, powerful idea. All the enormous complexity of managing, syncing, and building two separate style sheets is just gone. It's reduced to just one style sheet to rule them all. And the payoff for all this is just immense. By using these modern approaches, we've built an application that is blazing fast thanks to those precision updates. It has truly effortless maintenance because of that one universal style sheet. And most importantly, it achieves true inclusivity with an interface that's built from the ground up to support users all across the globe. A fast, global-ready front-end is a massive achievement. But, in the world of enterprise software, as soon as you solve one monumental challenge, it usually just reveals the next one. So the app is smart, yeah, but what happens when 10,000 different customers each need their own separate secure database? How do you possibly manage that without it turning into total chaos? Well, that's a challenge for another time.